Welcome to today's lesson on staad.pro. In today's lesson, we are going to be comparing the results from manual design to that of staad.pro. Okay, so in design of tension member, all we need to do is to get our design applied node, that is NED, and we need our NTRD, that is the tensile capacity of the section we are choosing. Then the code from equation 6.5 in the code says that NED should be less than NTRD. So it must always be less than or equals to 1. So it means that if 1 is 100%, it means that's the 100% of the capacity. So the NED should not be greater than NTRD. Okay. So in this case, now we're going to use an angle iron in the next video. So we have a bracing system taking an axial tensile load of 20 kilonewton. The strength of steel is 275 and the material factor is 1.0. So from what we know that from here we know that the strength of the material is equals to force over area. So if we make area subject of formula, we'll be getting an area of 73 millimeters square. So once we go to our angle section and go to our steel table, we can see that 20 by 20 by 3 equal angle section is going to work. So, and it said NTRD is going to be, so for us to get the capacity of this 20 by 20 by 3, we need to put it back into this equation and make this subject of formula. So we know our A is 1.12 times 100, so that's to convert it to millimeter. Then our Fy is 275. So once we put it here, we'll get that the capacity that 20 by 20 by 3 angle iron can take is 30.8, and what we have is the applied load is 20. So 20 divided by 30.8 is 0.65 and is less than 1, so it's okay. So what we'll do now is go to staad.pro to compare the results. So let's go back to staad.pro. Let's start. I just modeled a 1 meter beam and I assigned my section of 20 by 20 by 3 equal angle. Then the next thing I did was go to support. I put pin support at one end and I went to loading. So I applied a tensile load of 20 kilonewton. So you can see 20 kilonewton in the x-axis is going this direction. So if I change it to negative 20, see what I'll get. Negative 20 modify, yes. So you can see it's compressive already, which is not what I want. So I'll change it to positive, which is tensile. Okay, modify, close. So the next thing I need to do is analysis. So perform analysis, then design. So under my design, I have my code, then SGR, which is 275, what we are using, then track 2 for the calculation sheet. So here again, I can also put the national annex, which is going to be United Kingdom national annex. So I'll come here and look for NE and change it to UK national annex. So you can just add after current, close. So from there you just run the analysis and let's see the result if we have the same thing with the manual calculation. Okay, so post processing. So we have this. We can see our utilization ratio of 0.65, which is similar to what we had manually. So thank you for watching today's video on staad.pro. If you have any question, you can drop it in the comment section. Thank you very much.